we will start a brand new topic called estimating a population proportion. Estimating a population proportion. Whenever we talk about a population proportion, we talk about a P, right? And sometimes we use percent to show that, to express that instead of using the decimal, but it doesn't really matter. So we're going to use something to estimate a population proportion. If you learned in the previous classes, you know we have another thing called a P hat. Okay, what is this? This is the sample proportion. And before that, we also know N, that is the sample size. Okay, so you want to estimate the population proportion, but you cannot get the population. What you can do is you can get a sample of a sample size N, and then to find the sample proportion. And then we're going to use this to estimate the population proportion. That's what we're going to do. At the same time, we're going to learn how to find the sample size. What would be the sample size needed because we want to make a good estimate of the population proportion. And we learned something about a point estimate. If you remember, the sample proportion P hat is the best point estimate of the population proportion P, and it's also is an unbiased estimator. Okay. All right. Now let's look at the first example. Example 1. Right. Sally Mae conducted a survey of 950 undergraduate college students, and 53, so the sample size is 950 students, right? That's the people in the sample. And 53% of them said they take online courses. So we get the P hat, which is 53%. Or if you want to use the decimal form, it's going to be 0.53. So 53% of this 950 in the sample said that they are taking online classes. Based on this result, can you find the best point estimate of the population proportion? Okay, or you say, what's the best point estimate of the proportion of all undergraduate college students who take online courses? Find the population proportion, or to get a good estimate of the population proportion. All right, in this case, since we know that the sample proportion is the best point estimate of the population proportion, let me write it here so you can remember. Sample proportion is the best point estimate of the population proportion. Okay, that means the P hat is the best point estimate of P. Okay, so if I'm looking for the point estimate, just a single number, okay, the point estimate of the population proportion is just a single number, and your answer will be 0.53. That's your answer. Okay, so that's when we talk about the point estimate. We know this is the point estimate that is only at a certain point, but is this true? Not exactly. We can say that we make an estimate, but I don't feel comfortable just to give a number, because you have a really, really high chance that the actual population proportion is not this number. All right, so that comes to our new topic today. It's called confidence interval. What does that mean? The confidence interval means we're going to use the sample proportion to conduct, we're going to use the sample proportion p hat to conduct a confidence interval. And you remember that this is called interval, that a number, comma, another number, and then we use this parenthesis. So this is the confidence interval, or short for CI. Okay, we're going to build a confidence interval estimate of the true value of the population proportion. Okay, so confidence interval. I'm pretty much confident that the population proportion is going to be somewhere fall between this number and this number. So what do you think? This way is much better, right? Because you have more confidence. You have 95, usually 95, 99% confidence that the actual population proportion is in this interval. It's not just a point estimate. Point estimate just a single number. Now we're going to need a confidence interval. All right. Now usually we would like to have either 90% confidence interval or 95% confidence interval or 99% confidence interval. The higher level of your confidence, this is called confidence level, 99% or 0.99. The higher confidence you want to be, the wider the interval will be. Does that make sense? If you want to be more confident, if I want to be like a 100 confident, then the population proportion is going to be between 0 to 100%. Okay, and with the confidence level goes lower from 99% to 95% to 90%, and that confidence interval will shrink and shrink, right? So the smaller or the narrower the confidence interval is, the lower confidence level you could have. Make sense? All right, now what we want to know, the other thing is the confidence level. Confidence level. So it's either 99% or 90% or 95%. Okay, so what's that? We use that to show 1 minus alpha. Okay, so this actually, that means the confidence interval contains the population parameter, assuming that the estimation process is repeated a large number of times. So that means if you repeat this sampling work, you do this again and again and again, then 95% of the time that p hat is going to be in this interval, in this 95% confidence interval. All right, now this one is called 90%, 95%, 99%. It's called confidence coefficient or degree of confidence. Okay, so but what are we going to do about that? How do we find that? All right, now I tell you this. The confidence interval, let me just use this as an example. I want to be 95% confident that the population proportion fall between two numbers. Normal distribution, here's 0, here's z. If I want 95% confidence, so it's going to be somewhere around here. So here is 95%. Remember, the area under the curve is the probability. I want to be 95% or 95% of the chance the data fall within. If you remember, here's 1.96, here's a negative 1.96. It seems like the magic number to you, huh? And that will be 1.96 above the mean or 1.96 below the mean. And here, this is 95%. And this from here to here, that's your confidence interval. Okay, and I want to remind you something. When we use the p hat, compare the p hat with the p, and here will be the p hat, and then here is the p, and then do you remember what is the standard deviation of it? it's a quick review. Sigma will be PQ over N, but in this case we have P hat, Q hat, so it's going to be P hat, Q hat over N. And again, so this is 1.96 above the mean, this is 1.96 below the mean. Now, I will go over a little bit, how did I find this 1.96? How do I find this 1.96? If you're looking for 95% confidence interval, sorry, this is not a very good bell curve. Okay, so we want here to be 90.95, okay? And then what is this little area? Because this little area and this little area, they're the same. Because these two little areas will add up to 5%, will add up to 0.05. So each of them will be 0.025. So here is also 0.025. Okay, so if you have the z table, and I can use the negative z table, and this is a standard normal distribution table, and I'm looking for the little area to the left of a certain point, and that area, the little area, is 0.025. Can you find it? Did you find here? 0.025. So that z-score is a negative 1.9. And then if you go up, this is 6. So that's how you get a negative 1.96. And of course, the other side is just positive 1.96. Okay, there's a little way to write that. The z, I don't know if you remember this, z with a little alpha, that's the z-score. With the right tail is alpha. And this number is called a z alpha, right? That's what we learned before. And now what I'm looking for is, for 95% confidence interval, I'm looking for z alpha over 2. And 1 minus alpha, that's, you change that into 100%. That's your confidence interval. Okay, so 95% confidence interval, and in that case, alpha is 0.05. So 1 minus alpha is 0.95. So that's 95% confidence interval. And this alpha is outside the area, outside your confidence part. So that will be, the alpha is 0.05 and alpha over 2, because the confidence interval, right? We have right tail, left tail. So I'm going to divide it by 2. So in this case, it's going to be z 0.025, and which is 1.96. And the way we write that is z with a little number at the bottom, at the corner, and that alpha shows the area to the right of that z-score. So this is how you find the 1.96 and negative 1.6. We call that critical value. Critical value. All right. Now, very similar. Let's work on 90% and 99%. So if it's 90%, and this is, here's a 0.90, here's a 0, here's a z, right? So 90% confidence interval, what is the critical value? And each little tail is going to be 1 minus 0.9, which is 0.1, and then half of that is 0.05. 0.05. Okay, sorry, 0.05. And we look for 0.05, and you might not be able to find exactly 0.05, but you can find somewhere here. Here's a 0.05. Let's see, 0.49 here. Did you find this too? Okay, so that is a 5050, and here is a 4947. So 0.05 is kind of like in between these two. So I keep in mind here, and that is negative 1.6. If you go up, it's a 0.04 and 0.05. So it's in the middle. Therefore, our z 0.05 is 1.645. So that's another critical value. For 90% confidence interval, and the critical value is 1.645. Okay, one more. 99%. If here is 99%, I want from here to here, it's a 0.99. So this little tail and this little tail is going to be half of that 1%. So it's a 0.005 and 0.005. Okay, so let's find what is the z, 0.005. All right, again, I'm looking for 0.005, 0.00. Here's a 5, here's a 4, and did you see here? Sorry, 0.00508 and 0.00494 is somewhere between these two, so it's 2.575. Okay, do you see that? 2.575 in between these two, so that is 2.575. Okay, so these are the three very important critical values I hope that you can remember. And the most frequently used is this one. All right, for 95% confidence interval, the critical value is 1.96. For 90% confidence interval is 1.645. And the other one, 99% confidence interval. 99% confidence interval, the critical value is 2.575. Okay, so once we know this, I'm going to explain the next thing is, okay, you think about this one. From here is the mean for z, right? And here's 1.96, 1.96 away from the, that's how many standard deviations away from the mean. All right, now if you have 0, z, and you have p hat, and you have p, and the sigma is p hat q hat over n square root. All right. Now, if you have 95%, I always use 95% confidence interval because this is very frequently used. If it's 95% confidence interval, then I know here's 1.96 and here's 1.96. All right, so here, in order to get this number, that is going to be p hat plus 1.96 times p hat q hat over n. And this number, which I'm going to put here, is going to be p hat minus 1.96 square root of p hat q hat over n. So I will be 95% confident that the population proportion is between this number and this number. That is going to be our confidence interval. And what is from here to here? Okay. I call this margin of error E for proportion. So that's the maximum error. Okay, or we call that margin of error. This is margin of error. Okay, that is a z alpha over 2 p hat q hat over n. So that's going to be p hat plus minus e to get the confidence interval, right? So this is your the margin error, and this is the critical value, depends on your confidence level, and this is the sample proportion, and this is your sample size. Okay, and then the confidence interval will be just p hat minus e and p hat plus e. All right, now once we know this, we're going to say, how do we interpret the confidence interval? You're going to say this: we are 95% confident that the interval from this to this, from this number to this number, actually does contain the true value of the population proportion P. So I'm 95% confident that from here to here, in this interval, that population proportion P will fall in this interval. Okay, and we're not going to say that, well, actually the way we say that we're 95% there's 95% of the chance that the true value P fall between these two. Is that right? 95% of the chance that, no, that's not right, because the true value P is already a number. Okay, it is there. So there's no chance that this number is going to be here, it's going to be there. No, the P is already fixed. We just don't know it. So you don't say there's 95% of the chance that the P will fall between these two. You're going to say 95% confidence that this interval contains P. Okay, and you're not going to say 95% of the sample proportions will fall between A and B. You don't say it that way either. So remember, for the confidence interval, it's pretty important how do we interpret that. Now let's go back to the example. We have the Sallie Mae example. Sallie Mae conducted a survey of N, remember that, 950, right? And the P hat equals 0.53. That's many people. That's 53% of this 950 in our sample. They take online classes. Now, number one, can you find E? Can you find the margin error E? Okay, that corresponds to 95% confidence level. 95% confidence. Okay, and if you say here 95% confidence, then you're going to know the Z alpha over 2, the critical value is 1.96. All right, and the formula E is just P hat Q hat over N times the Z alpha over 2. Therefore, it's easy. It's going to be 1.96 times P hat 0.53, Q hat 0.47, right? That's just 1 minus P divided by 950. All right, so the margin of error E, that will be 0.032 or 3.2%. Okay, if you like to keep a little bit more decimal places, that is fine. So this is the E. Okay, if I ask you to find the margin of error E, that's that. And number B, to find 95% confidence interval for P. And do you remember, it's just this one? It's just a P hat minus E and a P hat plus E. So P hat is 0.53 minus 0.032 and 0.53 plus 0.032. All right? Okay, so that would be 0.498 to 0.562. That's the 95% confidence interval for P is this. Okay. All right. Sounds good. All right. Now, based on this result, can we safely conclude that more than 50% of the undergraduates take online courses? Can you say, well, I'm pretty confident, or am I safe to conclude that 50% more or more undergraduate students take online courses? Did you notice that this interval contains 0.05? Sorry, 0.5 contains 0.5. All right, so you cannot safely conclude because there is some part, this part here is a 0.5, and here's a 0.4, here's a 0.6, so 0.562 is here, and 0.498 is here. So that is your confidence interval, all right? Because you do have, there is a quite possible that even we don't know, the population proportion is less than 0.5 or 50%, so you cannot conclude that more than 50% of the undergraduate take online courses. All right? Make sense? Okay. Now, assuming that you are an online reporter, can you explain this once you have all those, after you learn statistics? Can you describe the result, including all the relevant information? Okay, here, listen carefully. Okay, I have that on the slides, but I want you to listen carefully. 53% of undergraduates take online courses. That percentage is based on Sallie Mae's survey of 950 randomly selected undergraduates. So did you see that? You mentioned the sample size, you mentioned the sample proportion. Okay. In theory, in 95% of such polls, the percentage should differ by no more than 3.2 percentage points in either direction from the percentage that would be found by interviewing all graduates. What does that mean? That means because of we have this sample size and we have this sample proportion, so the sample proportion 0.53, okay, the maximum or the margin error is about 3.2%. Okay, the percentage should differ by no more than 3.2 percentage point in either direction from the percentage that will be found by interviewing all undergraduates, which means the population proportion. Okay, that you have 95% confident that the actual population proportion of all the undergraduates who take online courses, that proportion is going to be between these two numbers, falls within these two numbers. We're 95% confidence about that. Okay. All right. Now, if I give you the confidence interval, okay, if I give you the confidence interval, the p hat minus e and the p hat plus e. If I give you, if this is a given, can you find a p hat and an e? If I give you two numbers, all right? So let's say this is a 0.52, this is a 0.54. If I give you this two number, can you find a p hat? Yep, p hat is right in the middle of these two. So p hat will be 0.52 plus 0.54 over 2, which is 0.53. Okay, p hat is the number right in the middle. Can you find an e? Yes, e is just whatever you use, either the lower limit of the confidence interval or the upper one, doesn't matter. So you can use the 0.54, subtract, minus 0.53, you get a 0.01. Okay, so this is just a quick little note. If you are given the confidence interval, you can easily find a p hat and an e. I think this is very straightforward, so we're not going to pay too much attention to that. All right, now let's look at another example. Okay, the article High Dose Nicotine Patch Therapy by Dale Hurt is published in a magazine. I'm not going to talk to detail about that. What they say is this. There is a statement there said, of the 71 subjects, 70% were abstinent from smoking after 8 weeks. 95% confidence interval is from 58% to 81%. Use that statement to find the point estimate p hat and the margin of error margin of error e. So n is 71. Okay, of the 71 subjects, all right, then 95% confidence interval is from 58% to 81%. Find p hat and e. So So we have the lower limit and upper limit of the confidence interval. Can you find the p hat? Yeah, the p hat will be 0.58 plus 0.81. Just add them up, divided by 2. You find the number right in the middle, which is 0.695. Okay, and the E will be just, you can use the upper limit minus this p hat. So it's 0.81 minus 0.695, which is 0.115. All right, or the other way is you can use the upper limit minus the lower limit and divide it by 2, which is the same thing, because the width of the interval is 2e. So if you use the upper value 0.81 minus the bottom 0.58 and then divide it by 2, you can also get this e. So that's the same thing, but this one is also straightforward. All right, now we learned how to get a point estimate of the population proportion. You're going to use the sample proportion. We learned how to construct a confidence interval, and we learned how, if you're given a confidence interval, can you find the point estimate and the E? Okay, so we learned all of those things. Now we're going to learn one last thing, is the sample size. Let's look at this formula. E equals z alpha over 2 square root of p hat q hat over n. All right. Now we have this equation. Can you solve this to find n? All right. Now first thing, you divided this both sides. Okay, so you divide it by that. You get an e divided by z alpha over 2 equals the square root of p hat q hat over n, right? Okay, and then because I don't like the square root, I take a square both sides, so I get an e over z alpha over 2 square, which is p hat q hat over n, right? Because I take square on both sides. And then what I'm going to do is, because the top is going to be e squared, the bottom is this, and then in order to solve for solve for n, I'm going to use p hat q hat divided by this. So n will be p hat times q hat divided by e over z alpha over 2 square. Okay, or you can, because you divided by the denominator, and there's a denominator in the denominator, you can flip it. So the answer is going to be p hat q hat z alpha over 2 square, and the bottom is going to be e square. All right, if you write it in a better way, it's going to be like this. It's z alpha over 2, that's a critical value, p hat q hat over e square. All right, now if I want to be 95 or 99%, I will give you the confidence level. If I have the confidence level, I want to construct a confidence interval to be with this width. Okay, the confidence interval twice of this width. 2e is the width of the confidence interval, or the margin of error e. What's the sample size you're looking for? Now here's a little tricky. You need to have the sample size first in order to get a p hat. Did you notice the problem here? How do you find a p hat? You already did a sample, right? You already find a sample. Of course you have the sample size. So what is that? When this p hat depends on two situations. One is p hat is known. You probably want to say, this is impossible. Okay, I tell you what, usually this p hat is not known without knowing the sample size. However, people might have some experience about that. I remember years ago when we do the direct mailing, we send a mail to customer and to see how many people actually open the envelope when they see that it was like a very clearly it's a commercial a mail, and what is the percentage that they're going to open the mail. From previous experience, the people, they told me it's a 0.8%. So we have some idea about p-hat. If you have some idea, this one even is not directly come from this sample size, that's okay. That's you have p-hat known, you just use that, okay, just plug that in. So you can get that either known from other people, expert or experience, whatever, okay. So sometimes it's known. What happens if p-hat is unknown? Use 0.5. Okay, if a p-hat is unknown, then we're going to use 0.5, which is 50-50. We just assume that p-hat is 50% and q-hat is 50%, 50-50. If you put in 50-50 here, p-hat, q-hat, this is going to be 0.25, right? 0.5 times 0.5 is 0.25. And then the sample size you get from this formula is going to be the largest compared with any other p-hat, q-hat value you plug in. All right, now if you have taken like I think a pre-calc or algebra 2, if you graph this, if you graph that, then you should have when x equals 0, when x equals 1, here's a 0, here's a 1, and that reached to, here's 1, here's a half, here's a quarter. So that's a quadratic curve. It looks like this. Okay, so p-hat times q-hat will reach the maximum at, when here's a 0.5, the maximum is 0.25. Okay. All right, so if you plug in x or the p-hat as any other number between 0 and 1, but not 0.5, not 0.5, then your p-hat times q-hat is going to be lower than 0.25. All right, well, this is a little extra. I'm not require you to, I don't ask you to prove that, but this is something that I hope you can remember is if you know p-hat, use p-hat. If you don't know that, use 0.5 to be safe. Your sample size will be large enough. All right, now we're going to have another example. Another example is a Pew Research Center surveyed 4,787 randomly selected U.S. adults. So we did a survey 4,787. Okay, and it shows that 79% of the respondents shop online. So those people shop online. All right, now that was so far we know. Now, if we want to conduct a new survey to determine whether the percentage has changed, how many adults must be surveyed? So what is our new sample size if I want to be 95% confident? Okay, whether the percentage has changed. Okay, how many adults must be surveyed in order to be 95% confident that the sample percentage is in error by no more than 3% of points, which is E is 0.03. All right, now did you see that they ask for N and they give you 95% CI and they give you E? Now if I look at this formula, for 95% confidence level, I know how to get this, 1.96. And a p-hat, q-hat, even I don't know that, but I have some historical data, 0.79, 79%. So I use that one. And then the error is 0.03. So I'm going to use the formula, N is Z alpha over 2 square p-hat, q-hat over E square. So for 95% confidence interval, that is Z alpha over 2, or the critical value is 1.96. So it's 1.96 squared times, and the p hat is given because that was the previous experience we know. Q hat is 1 minus that, or you just write, or you can just write a 0.21 right away. And the denominator is 0.03 square. Don't forget there's a square here and there's a square here. So once you have all those numbers, and you're going to have the answers is 708.1. Now, since you're looking for the sample size, which is how many adults that are going to include in your survey, so you have to round it to the next highest number. So it's going to be 709. That's your answer. Okay, so don't round down because the 708 is not enough. Even the next number, the next digit after the decimal point is 1. We still need to round up. We always round up. Okay, we always round up. Unless you have exactly a whole number as your answer, then you can keep it. So we need to do the survey of 7 and 9 people. All right, now let me quickly ask you another one. Ask you another question. Assume that we have no prior information. We don't know about this 0.79. If we have no idea about this, we don't know this information, and then what will be our sample size? Remember, if you don't have any information about p hat, you're going to use 0.5. Okay, so let's try that. That would be zf over 2 square p hat q hat. Of course, we don't know. So we're going to use, here's 1.96 square, and we can use 0.5 times 0.5 over 0.03 square. Okay, or you can just write here as a 0.25, which is the same thing. Guess what? You have 1067.11. So you're going to round up to 1068. Okay, did you notice that? Knowing some previous information, then you don't really need a large sample size as compared with not knowing. So this gives you the maximum sample size that you need. All right. Okay, so here is the everything you need to know about the estimating a population proportion, how to estimate P, to get a point estimate, to get the confidence interval, to get the sample size, and you get familiar with the critical value and E, margin of error, and all those concepts. They're all embedded in this session. I hope you're okay with that now.